have a topic called alkanes, but this is a subtopic under the hydrocarbons. Hydrocarbons. It's very clear, the compounds which contain only hydrogen and carbon are known as hydrocarbons. These hydrocarbons are divided into the two types. This is a classification, in fact, very briefly I will explain. And these are open chain compound, there is no cycles, open chain compounds and cyclic compounds. Open chain compounds also called as aliphatic compounds. Aliphatic compounds. In fact, aliphatic is a word which is used to show the opposite word to the aromatic also. But here the aliphatic means it is not cyclic, okay, ring type of compounds and the open chain type of the compounds, right. So, open chain compounds may be classified again into the two types, saturated and unsaturated. Saturated and unsaturated. Under the saturation directly example is the alkanes. Now, can you define what is alkane? Alkanes are nothing but the saturated aliphatic hydrocarbons. The best definition is the saturated aliphatic hydrocarbon. That means they will have all sigma bonds. Saturated means all sigma bonds. Aliphatic means open chains, and they are made up of the hydrogen and the carbons. Under the unsaturation, we have again two types. Compounds with double bonded, okay, containing double bonds, containing triple bonds. So, now the double bonded compounds examples are alkenes. These are the examples for the alkynes. Under this cyclic, we have again the two types. You can divide into the saturated and unsaturated. So, saturated we have cycloalkanes. They are like alkanes, but the only thing is rings are there, for example, a cyclohexane and so on. Unsaturated compounds, we have huge number of types, but one of the specific type will be the aromatic variety, that is a compound which is containing 3 double bonds alternatively, specifically known as what? Benzene. So, we have here these 4 chapters are there: alkanes, alkenes, alkynes and benzene. Unfortunate or fortunate, the cycloalkanes is not there, and the other the benzene type of compounds also are not there, only the benzene with the small groups attached to the benzene we have. So, therefore, we are going to take first alkanes, then next by the alkenes. What is the definition of alkenes? Alkenes will be the unsaturated aliphatic hydrocarbons with double bonds as a functional group. Unsaturated aliphatic hydrocarbons with triple bond as alkynes is this one. Under the benzene is in a specific type of unsaturated, but aromatic systems, all contains the aromatic nature. Aromatic system containing unsaturated cyclic hydrocarbons are, one example is benzene. However, the benzene containing some alkyl groups like methyl, ethyl, or generally alkyl groups attached to the benzene are called arenes also. We have one specific observation, arenes. Okay. Right now let us take the first alkanes. So, the alkanes will take the luster is not there. So, let us now focus on the alkanes topic, their preparations and properties. We are going to see a gist of the preparations and properties. How these alkanes are prepared. In the preparation, in general, we have one understanding. All these organic chapters are arranged in a particular manner: alkanes, alkenes, alkynes, benzene, halogen compounds, hydroxy, and then we have a carbonyl compound, acids and acid derivatives, nitrogen. This is the sequence of the organic compounds. In this sequence, let us say 1, 2, 3, 4, 5 and so on. So, if at all third chapter compounds we want to prepare, 1 and 2 compounds if you oxidize, you will get the 3 compound. Okay. Similarly, if the rest other chapter compounds reduction will give the third chapter. So, this is the one principle involved in the arrangement of the more the oxidized the compound will be at the end. So, therefore, the alkanes are the compound 1. Can you answer now? What methods are there for the alkanes preparation? Definitely all other chapters if you reduce you will get the 1. So, obviously all the preparations of the alkanes will be the reduction methods of different varieties, right. So, all other chapters if you reduce you will get it, but for all the compounds the reducing agent cannot be the same, isn't it. So, therefore, we are going to see what are the different reagents used to reduce the different types of the compounds to get the alkanes. Sometimes a 5th chapter may not give directly 1, 5th chapter may give third one, and the third again reduction may give the 1. So, that we are going to see. The first one is the I said reduction only, reduction of alkenes and the alkynes. This is the best method, ene and yne chapters, that is double bonded compounds. Triple bonded compounds if you reduce with a set of 1 hydrogen. So, 1 hydrogen will be added here, 1 will be added here to get a alkane. This is the best method and the simplest method also. This is called what? Adding the hydrogen. So, overall it is a reduction, but adding the hydrogen is specifically known as what? Hydrogenation. Hydrogenation. The method is in fact it is a stable compound, these two should react, but the optimum conditions are nickel around 200 degrees centigrade it is identified, it is a suitable catalyst. Catalyst will not start the reaction. Already reaction will be taking place even in absence, but in presence of nickel the reaction will take place fast. Nickel provides a solid surface. In fact, the mechanism if you go to the details, alkene is adsorbed on the nickel particle, okay, then side by hydrogen will be adsorbed, slowly a transition type of the intermediate stage is found. It is not step 1, step 2. Both the hydrogens simultaneously, the old bonds will be disappearing and the new bonds will be forming. Hydrogen will come from the one-sided attack and then slowly the molecule will come out as a what? Ethane is formed, and this ethane will come out as a molecule. So, the setting of the molecule is called adsorption, and coming out of this from the surface of the nickel out is called desorption. In between that, when they are that is attached to this with the physically, that is called adsorption forces, the reaction is taking place. Nickel is acting as a surface on which they adsorb and then come out. This is the mechanism. This is neither a electrophilic or a nucleophilic free radical addition. This is a concerted mechanism where the hydrogen molecule is totally molecular addition, from one sided it is adding. So, therefore, you have some problems here, like the addition goes to a cis type of the or syn type of the addition. Now, let us go for the second method of even alkyne. If you take alkyne also, in the first step you will get the alkene, and the second step you will get the alkane. That is, it requires 2 stages. The second method will be the again a reduction. As I said, all are reductions, but the reduction of what? RX, alkyl halides, can be reduced to using the 2 nascent hydrogen molecules. Can you add hydrogen and get this reaction? No. To break this sigma bond, we need a reactive hydrogen. This can be obtained by the several methods, like any metal like tin and HCl will generate the nascent hydrogen. In addition to this formation of the metal halide like zinc stannous chloride will be formed. This nascent hydrogen will be used in this reaction. If 2 HCl is taken, 2 nascent hydrogen will be used here to cut here, and you get a RH and the HX. This is another method of the preparation. This is called reduction of alkyl halide. However, this is not hydrogenation because it is not addition. By breaking you are adding, you may call it a hydrogenolysis. Hydrogenolysis. Nolysis means a fission of the bond, sigma bond we are cutting. So, therefore, we are calling it as a hydrogenolysis of the alkyl halide. We will get the alkanes, right.